Hey guys, I'm back again. I'm going to show you how to do a couple of questions on Boyle's Law. I said that the only formula that you have to memorize is simply V1, V1 over T1 equals P2, V2 over T2. All right. So again, just don't forget that your temperature must be in kelvins. All right. So when we change them to kelvins, remember that you have to add 273 to your Celsius reading. Okay. So let's go ahead and do Boyle's law. Boyle's law relates pressure and volume, correct? So therefore, we're not going to look at temperatures. We're simply going to be using, I'm sorry about that. So let's Yes. So we're going to be only using this formula. And that's the reason why you have this formula right here, okay? So let me show you how to do a couple of problems right here. So for number one, well, read the directions first, okay? All right, so it says solve the following problem assuming constant pressure. Well, assuming constant pressure because temperature, since it is constant, so we're not looking at it. All right, so for number one, it says a sample of oxygen gas occupies a volume of 250 milliliters. Look at the unit right here, it's milliliters. That's your volume, right? At 740 torr pressure. All right, so there's another given that is, it says it's pressure. If you remember the video that I showed you, that one of the pressure units is torr. So even if it did not state here that that's pressure, the fact that you see the unit torr, that should tell you that's pressure. All right. And then the question is what volume? So notice that you're also asked for another volume. Will it occupy at 800 torr pressure? Oh, another pressure. All right. So if you see that you have more than one of each, it should tell you that you're actually using the gas laws. All right. So you have the initial condition and the final condition. So you have first and second condition. So what I do, it doesn't really matter which one is you would set up as ones and which ones you would set up as twos, as long as they are like paired correctly, then you should be fine. All right. So what I actually do is simply assign one for the first volume or first pressure that I see. For example, this one. I see this as my first volume, so I would assign that as V1. All right, so that's my V1 right there. Notice that this is the pressure at V1, so therefore that's my pressure 1 as well. Does it make sense? All right, now notice that you're looking for another volume. So if I already have V1, this must be my V2. So I'm looking for V2. All right, and then the pressure at V2 is 800 torr, and so that's my second pressure. Okay, so now that you have already identified your given numbers, all right, you can go ahead and use the formula now, which is P1 V1 equals P2 V2, all right, and simply plug and chug. However, make sure though that when you plug in the numbers, that units must be consistent. For example, for pressure, if your pressure unit is in torr, the other pressure must also be in torr. So therefore, since we're looking for volume right here, since the volume unit given here is milliliters, therefore when you put your final answer, the volume must be in milliliters. Okay? Does that make sense? I hope so. All right, so now we're going to plug in the numbers. As said, as long as the units are consistent, you may just ignore the units for now. All right, just the numbers. So plug in 740 because that's our P1. Our V1 is 250 equals P2 is 800 and V2 is a known, right? So that's our X. Now, do you remember how to solve this kind of equation wherein we are solving for the unknown? Well, I virtually hear you. Yes, you have to divide both sides by 800. All right, so go ahead and divide by 800. So I'm just writing over this because I don't have enough space. All right, and that should cancel my 800. And now I will have So what I would do, I will multiply these two numbers and divide it by 800. And of course, you have to follow significant figures, okay? So let me grab my calculator. So we are multiplying 740 by 250. You press equals sign and you divide by 800. And you should get 231.25 milliliters. Again, it is milliliters because it is volume, and the volume given, the unit that is given for the volume in this problem is milliliters, so you answer in milliliters. I have Paco in the background. All right, so therefore, since we are supposed to answer in correct significant figures, what we have to do is you have to go back to the original problem, right? And count the number of sig figs there and choose the smallest. And of course, this one has 3, this one has 3, this one is 3. You must have 3 sig figs, so the final answer must be 231 milliliters. All right? Does it make sense? All right. Okay, so now let's move on to number 2. Okay, so for number 2, so let me just erase this part right here. All right, let me undo these part. Okay, so that it will be just clear over here. So we know that this is 231 milliliters right here. All right, for the second question, it says, a sample of carbon dioxide occupies a volume of 3.50 liters. Okay, so that's your volume. So that's our first volume right there. So that must be your V1 at 125 kPa. So that's your pressure at V1. So that must be P1. What pressure? All right, so that's your second pressure. So you're looking for pressure. Would the gas exert if the volume was decreased to 2.00 liters? So there's another volume given. So that's your second volume right now. All right, we know that this relates pressure and volume. So that's Boyle's law. So we're going to go ahead and write down the formula. P1 V1 equals P2 V2. Yes. P1 V1 equals P2 V2. And then we have to make sure that the units are consistent. All right, for volume, it must be in liters. And we're looking for pressure. Since the pressure unit here is kPa, our pressure after we calculate it must have units of kPa. All right, so we plug in the numbers. P1 is 125. V1 is 3.50 equals, P2 is a known, so that's our X. All right, and our V2, all right, is, what is V2? It's 2.00 liters. All right, then again, you'll do the same thing. You multiply by 125 by 3.50, then you divide by 2. And of course, you have to answer in correct significant figures. All right, so we multiply those. Hey, stop, Paco. All right, so 125 times 3.50 divided by 2 will give us 218.75. And this is pressure, and the pressure unit given here is kPa, so we answer in kPa. However, we are not going to answer with all of these numbers because in chemistry we follow sig figs, and there are 3 sig figs here, so which gives you 219 kPa. All right, so again, what we have to do here is simply follow the formula. All right, and the beauty in chemistry for the topics that have formulas is you simply do plug and chug. You just substitute, just like in algebra, right? So we substitute, but you have to be cautious though that the units are consistent. What does that mean? If pressure is in torr, it must be in torr, okay? Now, if it's notes that I gave you last time on pressure conversion, where they are all equal to 1 atm, all right, which is atmosphere. I hope this podcast help you do Boyle's Law, and I will see you very soon. Have a great day. Bye-bye.